Welcome back to our continuing series on becoming an evidence-based analyst. In this installment, we will begin our instruction of the process involved in step 3, evaluate the evidence. This step forms the core of evidence-based analysis. There are multiple techniques involved in evidence evaluation. In this tutorial, we will focus on rating the quality of the method used to gather and analyze the evidence. As with each tutorial, we will begin with a quick review of the steps of EBA. This review is provided to ensure that you are clear where this tutorial fits within the overall process of evidence-based analysis. Then you will learn the 9 levels of evidence quality. The quality ratings will be separated into 2 groups. First, we will discuss the 5 levels of backing. Backing provides important examples and explanations for why and how the effects occur. Next, we will discuss the 4 levels of grounding. Grounding enables us to evaluate the predictions of effect size made in a warrant model that supports the claim. As discussed in previous tutorials, evidence can support a claim or provide reservations about a claim. Each level of evidence increases the confidence we should have about the evidence being presented in an article that backs or grounds a warranted claim. After presenting each level of evidence quality, you will learn a step-by-step process for quickly assessing the quality of evidence. At the end of the tutorial, you will be provided a link to a practice exercise to develop your skill at rating evidence quality. As we progress through each step of this tutorial, you are encouraged to frequently pause the playback to take notes or to practice the step on your own. As with all EBA skills, or any important career-relevant skill that you'd learn, you will need much practice to develop your ability to accurately assess the quality of a published study. As discussed in the previous tutorials, there are 4 steps required to perform EBA. These steps allow us to develop or evaluate a claim statement. Each of these steps involves multiple techniques that must be mastered to become an evidence-based analyst. Accordingly, the tutorials for each step are broken into parts to allow you to gain understanding of the concepts and then apply them in practice exercises to develop the skills needed to perform each step. We have previously discussed the processes of asking an answerable question and developing a warrant model. In step 3, we evaluate, compare, and systematically analyze the effects of the substantive factors across a variety of settings. Finally, in step 4, we assess the risk of an evidence-based recommendation. The 9 levels of evidence quality are shown on this slide. In a sense, the first isn't really evidence at all. A paper that simply makes claims without conducting a study to support those claims is called a theory or essay paper. You will find many examples of this type of paper on the web as you search for evidence. Consequently, the first level is assigned the quality level 0 since a theory or essay does not provide data supporting a warranted claim. Even though a theory paper doesn't provide data, it can and will often be used to back a claim. You will often find theory being used as backing in a book or in a literature review section of a scholarly paper. However, it would be better to have some indication that the author is at least an expert or has gathered the expertise of others to increase our confidence in the opinions being expressed. The expert opinion or qualitative literature review is the second level of evidence quality. In this type of study, the author has selected specific individuals or prior publications that support their claims. However, the selection of studies means that the author may have omitted evidence that would pose reservations for their claims. Relying only on a selective analysis increases the risk of committing several common reasoning fallacies, such as bandwagon appeals, hasty generalizations, circular reasoning, testimonials, or card stacking. You should be very careful of backing your claims with a paper that commits one or more of the 13 common fallacies. To better understand these fallacies, you should watch the 11.5-minute YouTube animated video, 13 Fallacies. We now turn to evidence that systematically analyzes data, rather than reporting what the author or an expert believes. The first is the case study. A case study is an uncontrolled observation of behavior. We say it is uncontrolled because the researcher does not control the environment surrounding the case. Case study data is frequently collected through interviews or site visits. A case study analyzes a single person, a single organization, or a single event. Though limited in scope, a well-constructed case study provides a rich narrative description, including examples and explanations that may back or pose reservations for the predictions of a warrant model. However, while based on gathered data rather than an author's or an expert's opinion, a single case study can involve considerable bias in the selection of the case. The data gathered may only apply to the one instance studied. We can therefore gain increased confidence in a claim when it is backed by observations drawn from multiple cases, or better yet, by analyzing all the studies that have been previously conducted by others. In the multiple case comparison, the warrant model can be tested by contrasting the nature and extent of the effects across multiple settings or instances of an event. Alternatively, by preparing a narrative summary of prior research, we can gain increased assurance that the data has been gathered from multiple people or across multiple conditions or settings. However, since the comparative case lacks a statistical analysis of the effects, the multiple case or narrative review does not allow us to estimate the size of an effect. Therefore, we can further increase our confidence in a claim by statistically analyzing data collected from many people through a survey. A single one-time survey asks a group of respondents, a cohort, to think back, retrospectively, to how they felt or thought in recalling their response to a question or statement. The study surveys across an entire sector of people at one time. For this reason, we refer to these studies as retrospective cohorts or cross-sectional studies. The retrospective cohort study not only provides an aggregation of opinions, it enables the calculation of descriptive statistics and a correlation estimate of the effect size of a cause on an outcome. However, we must remember that correlation is not causation. To know if a cause is affecting an outcome, we must be able to determine if changes in a causal factor are associated with changes in the outcome. Since all factors are measured at the same time, the survey responses do not allow us to determine if the outcome changes over time as the level of a causal factor changes. A one-time survey cannot control for other factors in the environment. Finally, because the survey respondents are not randomly selected for the study, the results may be biased by who responded. Because they do not enable us to assess the probability and size of a change in an outcome factor, the first 5 levels of evidence quality can back, but do not provide a solid grounding for the predictions of a warrant model. For that, we need to look to the next 4 levels of evidence. The 9 levels of evidence quality are separated into 2 groups, backing and grounding. Backing is provided by the quality ratings 0 through 4, the first 5 levels. Grounding is provided by the last 4 levels, quality ratings 5 through 9. Grounding is evidence that uses inferential statistics to estimate the effect of a causal factor on an outcome. These levels of evidence enable us to control for some other factors that could provide an alternative explanation of the results. By reducing the number of factors that could explain a change in an outcome, the 4 levels of grounding raise our confidence that a causal factor is impacting the outcome we desire. A prospective cohort study is similar to the retrospective cohort study in that it is a survey of others' opinions. However, because the survey or observations are repeated over several points of time, we are able to see how the opinions at one point in time bring about prospective change in an outcome. The longitudinal nature of this type of study enables us to begin to make inferences regarding the causal relationships between one factor and another. However, because the findings are not controlling for how much the causal factors may impact each other, there remains considerable potential bias in the data. The quasi-experiment study uses statistical techniques to control for the effects of the modeled factors on each other. These studies enable us to tease out of the data the direct and indirect effects of a cause on an outcome. They also allow us to begin to understand how some factors may be intermediate causes because they mediate or moderate the effect of a root cause on an outcome. More importantly, the quasi-experiment enables calculation of the predictive quality of different models and their effects. Using these techniques, we can determine which model best fits the data and which provides the best explanation of the results. In other words, the best path from cause to outcome. Consequently, as you learned in step 2 of EBA, we often use path models created by structural equation models, hierarchical linear models, fixed and mixed effects models, and other quasi-experimental modeling tools to develop our warrant models. By being able to distinguish the effect each causal factor in the model has on the outcome factors, we increase our confidence in selecting factors to use to create the results we desire. It is, though, very important to remember that you cannot use the effects found in a warrant model study as evidence for that warrant model. Evidence must come from another study, perhaps another quasi-experimental study, rather than the study that was conducted to produce the original model. Quasi-experimental studies also use a selective sample from which the data is gathered. It is possible that those selected to participate in the study differ in some systematic way from other members of the population that we are trying to predict. In other words, potential bias and risk is introduced into the data by not being able to control for some other factors that are present in the people we selected. Therefore, we could raise our confidence in a claim even higher if supporting evidence reduces sample bias. By randomly selecting subjects or using experimental techniques that control the conditions, we gain increased confidence that the causal factors are producing the outcome differences in behavior. However, every grounding study still contains statistical artifacts that can bias the findings. We can never fully eliminate these statistical biases, but we can measure them. The highest quality evidence, therefore, the meta-analysis, performs these corrections. The best of these studies calculate confidence intervals that provide specific ranges of effect sizes for causal factors. We can use these confidence intervals to determine how certain we should be. The certainty interval, or the confidence interval, is provided with either a 90 or a 95% confidence. Rating the quality of evidence is essential to determine how much confidence you should have in a prediction, a recommendation, or an explanation that you or someone else claims. You will find that many studies that people reference in supporting their claims are of rather low quality. High-quality studies oftentimes create reservations that might limit or invalidate a claim. So how do you quickly rate the quality of a study? The first thing to remember about rating evidence quality is that not all papers follow the same format or use the same language to describe their studies. While peer reviewers are used by the best journals to regulate how evidence is presented, not all journals use the best peer reviewers, or may not even use them at all. Consequently, the process that we use for rating evidence quality must be viewed as a guideline rather than a set of rules. You will find papers that don't conform to common practices. These may be more difficult or time-consuming to evaluate. In this tutorial, you will be learning a rapid rating technique that will work with most papers. This should especially be true for papers with high citation rates that appear at the top of Google Scholar listings. Often these papers have been published in high-quality journals that use the best peer reviewers. The steps outlined in the rapid rating approach should enable you to create an initial judgment of paper quality in less than 2 minutes after opening the paper. In future tutorials, we will be reviewing each of the study types in more detail. It will take some time and much practice to develop a deep understanding of each type and level of evidence quality. Once you understand the type of information provided and the format of each evidence level, you will be able to verify your rapid rating by examining the paper's tables and charts. Each step outlined in this rapid rating technique should be followed literally. Each quality rating question is answered as either yes or no. Based on your answer to the question, you either apply a rating or continue with your assessment. You must follow the steps in order to obtain the correct rating. We search for backing from the lowest level up. We search for grounding from the highest level down. In order for the rapid rating technique to work, you must be able to search the contents of the paper. This often means that you should download the paper in PDF or HTML format first before attempting to rate it. You should also verify that the text in the paper is searchable. Text is made searchable by using optical character recognition, or OCR. For further details on how to verify that you have downloaded an OCR-ready text, watch the YouTube video entitled Using Adobe Acrobat to do Optical Character Recognition, or OCR. The first step in the rapid rating technique is to search for a method section header in the document. The section header, usually in bold print, can also be titled Methodology, or rarely some other section header that signifies that the section will describe how the study was conducted. If we do not find a method section in the paper, the purpose of the paper must be to make propositional claims or to review claims or evidence created by others. To determine whether the paper is an essay or theory paper, quality rating or QR of 0, or if it is a review paper, QR1, we can search or scan the abstract or first page of the paper for the word review. If the purpose of the paper was to review prior literature, then the paper should be rated a 1. Otherwise, it is a 0. If we found a method section in the paper, we proceed to step 2 of the rapid rating technique. In step 2 of the rapid rating technique, we first search for a section heading in the paper that is labeled Results or Findings. If this heading or something similar is found, then we quickly scan down through this section to locate tables that provide statistical information, such as means, standard deviations, correlations, or other statistical indicators. If we do not find statistical tables, then we conclude that the paper must be a qualitative study, which means it will be a QR2 or 3. To determine which of these two ratings is appropriate, we need to identify if the paper is a single case study or if it is comparing case data from multiple case studies, or by creating a narrative review of prior research. We make this determination by returning to the method section. We quickly scan the method section for a description of where the data for the study came from. Was it a single case study or multiple case studies? If a single case study, the paper quality is a 2. If the data came from multiple case studies or was a review of prior evidence, it is a 3. If we did find statistical tables in the results section, then we know the paper is reporting some form of statistical analysis. To determine which type of statistical study was conducted, we search the paper using the find function for the word phrases corrected correlation, or confidence interval, or phi coefficient, which will display in a table as the Greek letter phi, like a P but with a longer stem. If we find any of these word phrases in the text, then the paper is reporting a form of meta-analysis which should be rated as a quality of 8, or QR8. If we do not find the meta-analysis word phrases, we use the find function again to search for the word random. If we find that the word random appears in the paper, we need to verify that it relates to the sample used in the study. We want to be certain that a random selection or random assignment was used to sample the population. This information should appear in the population subsection of the method section that describes the participants in the study. If you are uncertain where to find this section, you should review the tutorial entitled Step 2, Develop a Model, Part 2. In this tutorial, you learned how to locate the population section of a paper to develop your PICO summary. If we conclude that the population was randomly sampled, we rate the quality of the paper as a 7, or QR7. If we don't find a reference to random sampling, then we search for word phrases that indicate the use of quasi-experimental techniques that permit model comparisons. These words are structural equation, hierarchical, or path, used in proximity to the word model in the method or results section of the paper. If we find these words, this is a QR6 paper. If we don't find the QR6 words, then we search for a reference to longitudinal, or time, in the paper. We are searching the text to determine if the study was conducted over time, or at only one point in time. If the study was a longitudinal study, with data provided at time 1, time 2, etc., then we'd rate the quality of the paper a 5. If not, this is the highest form of backing study, a QR4. You are now ready to begin practicing the rapid rating technique. This slide provides a summary of the 2 steps. You may want to print this slide. Keep it beside you as you rate studies until you feel that you have memorized the steps of the process. In future tutorials, we will be showing examples of paper quality ratings. Those tutorials will provide further instruction on how to verify that the rapid rating was correct. However, you should not wait to watch these tutorials before begin practicing the rapid rating technique. Much evidence indicates that you will learn this technique best by trial and error. The URL listed at the bottom of the screen will take you to the Evidence-Based Analysis Quality Rating Assessment practice exercise. You will be presented links to 27 different papers to assess in random order. A copy of all of these papers is provided in the File section under Practice Exercises. Therefore, you should not need to use the links provided in the practice exercise to access the paper. Not all of these links will work for all people because of library access limitations. So don't forget to get a copy from the File section, again, listed under Practice Exercises. However, if you wish, you could try to access the paper from within the assessment also. You may access this exercise an unlimited number of times. Most people find it takes 15 to 20 tries before they are able to master the rapid rating technique. Each time you rate a study, you should consider how confident you are in your rating. Whenever you are not absolutely certain or highly confident in your rating, you should make a note of which paper you should study in more detail before rating it again. Please remember that the quality rating assessment exercise contains 3 papers of each type of evidence. 9 times 3 equals 27 total papers. If you like, you could keep track on your own of how many papers you matched with each of the 9 levels of evidence. Every weekend, I will review the score data. I will then provide you with detailed feedback on your accuracy in rating each of the 9 levels of evidence. Based on this feedback, you should decide which of the supplemental tutorials on each type of paper you may want to watch next. Finally, the File section also includes an example of each type of paper. The title of the file indicates the QR rating that is appropriate for that paper. You can use this list of files to practice your rating skills before or after taking the quality rating assessment. Generally, people learn best when they try the quality rating assessment exercise first, using the guide provided on this page to rate the evidence. Then, after you have received some feedback on the quality levels that you have not mastered, take a look at the sample papers to see if you can determine what you missed. Finally, you should post a question in the discussion forum to get assistance on how to properly rate studies that you may find especially challenging. Now it's your turn to practice. Click the Try It Now link to get started. For those with access to Canvas and IUSB, this link is also provided in the practice assignment for the EBA Quality Rating Assessment. For those who are accessing this tutorial from the Evidence-Based Management Google+ community, you can find the link shown on this page in the comments section of the YouTube video.